I've seen a lot of people go after the cheapest hobby mills on a whim, only to end up with a wobbling spindle, a table that slides out of alignment, and a whole lot of frustration when they finally try to cut anything more precise than a piece of cardboard. The regret that follows is almost immediate. The machine looks promising on paper, but the reality is a shaky mess that eats up time and money. That's why, before I even pulled this unit out of the box, I made a point to look at the real-world trade-offs. Link is in the description if you want to check the product details on Amazon, and it helped me keep my expectations honest as I dug into the specs and the handful of community posts that actually talk about day-to-day use. What's interesting about the INTBUYING mini milling drilling machine is that it sits in that sweet spot between a tabletop hobby router and a full-size benchtop mill. At 5 inches by 20 inches, it's compact enough to live on a crowded workbench, yet the 600-watt variable speed motor gives it enough torque to cut through inch aluminum or a thick piece of hardwood without stalling. The real question is whether that combination translates into a tool you can rely on for the little projects that keep hobbyists and makers moving, like fabricating a small bracket for a 3D-printed enclosure, drilling precise pilot holes in a wooden gearbox, or even machining a tiny aluminum spacer for a custom drone frame. If you're the kind of maker who likes to prototype parts that will actually go into a functional device, this machine feels like a smarter buy than the ultra-cheap alternatives that often lack variable speed control. The variable speed range, from a low 200 revolutions per minute up to about 3,000 revolutions per minute, means you can dial in the perfect surface speed for each material. I spent a few evenings testing it on pine, acrylic, and a scrap piece of 6061 aluminum. On pine, the low end of the range produced clean, burr-free cuts, while the higher speeds let me finish the cut quickly without burning the wood. With acrylic, the microfeed precision thanks to the fine-threaded lead screw allowed me to move the table in increments as small as 0.01 millimeters, which is a lifesaver when you're trying to trace a laser cut pattern that's only a couple of millimeters wide. The real test came with the aluminum. At around 1,500 revolutions per minute the mill held its line, and the upgraded grinding table, which has a flat, hardened surface, kept the workpiece from wobbling under the cutting load. I did notice a slight vibration at the highest speed settings, but it never translated into a loss of dimensional accuracy for the small cuts I was making. Who should buy this? If you're a hobbyist who already owns a basic drill press and you're looking to add the ability to mill shallow pockets, cut slots, or drill precise holes in a single setup, the INTBUYING mini mill is a logical next step. It's also a solid choice for educators who need a compact, relatively low-cost machine for a classroom where space is at a premium. The inclusion of MT2 and ER32 drill chucks means you can swap between standard drills and milling cutters without having to buy a separate chuck set, which is a nice time saver when you're juggling multiple projects. On the flip side, if your plan is to take on heavy-duty machining like deep pockets in steel, large-scale production runs, or anything that demands high rigidity, the mini mill will start to feel under-engineered. The table, while upgraded compared to entry-level models, still has a modest load capacity. I quickly discovered that trying to mill an inch-deep groove in a solid piece of aluminum caused the table to flex just enough to make the cut edge slightly ragged. For those kinds of jobs, you'd be better off saving up for a larger spindle mill with a cast iron base. One of the practical strengths of this unit is the tilt functionality, which lets the spindle angle up to 45 degrees in either direction. That feature opened up a few creative options for me, like drilling at an angle to accommodate a sloped surface on a prototype enclosure. The tilt mechanism is smooth, and the locking knob holds the angle firmly enough that I could mill a small bevel without the spindle drifting. Another plus is the microfeed precision I mentioned earlier. The lead screw is a 1 mm pitch, and the handwheel offers a very tactile feel. You can make tiny adjustments without worrying about slipping, which is something you rarely get on the cheap models that use cheap plastic gears. However, the machine isn't without its hidden trade-offs. The spindle's variable speed control is a dial rather than a digital readout, so you have to guess the RPM based on the dial position or use an external tachometer if you need exact numbers. That decision keeps the price down, but it does add an extra step for anyone who works to tight tolerances. Also, while the base is sturdy enough for a benchtop setup, the footwork is a simple set of rubber pads. On a particularly resonant workbench, you can hear a low